bottom fold, dormer glass solution. We're in Lita, external vertically lit solution. We do all kinds of glass products as well. Today we have Terry Lawrence with us, our regional manager for Skyfold. She'll be presenting acoustic separation using motor-driven partitions. Any questions you have, feel free to ask during the presentation. We'll try to find as possible. It's a large group, so we can try and get through it as fast as possible. Guys, at this point, I'm going to turn it over to Terry.
Hi there. Thank you for having me. Welcome from other parts of the country, too, or at least the state of Virginia, right? I have a friend who calls that the motherland. So welcome from the motherland. We're going to talk about, as James said, acoustic separation. Please stop me if you have a question. I'm happy to answer whatever I can. Sometimes it's easier when we're on that topic. So we're going to talk about the importance of flexible space division. We're going to talk about electrically powered partitions and what's available to you. We'll talk about acoustics. We'll talk about structural support. And then ultimately, I get the weight for how much. And I'll try to kind of give you an idea of where everybody falls in that marketplace. So if we can, for instance, drop a wall where we are today and create two spaces, we better utilize the space we have available. And that's really what all of these partitions are used for the most part, and for acoustic separation. We also, though, see them being used as traffic and security control. In fact, we have 10 walls going into the new Reagan National TSA area. They're going to use the walls to open and close in TSA during peak times and unpeak times. And then generating additional revenue. If you think about the big giant ballroom in a hotel, when they can divide that room 6 ways to Sunday, they make a lot more money than they do when they just rent the one big giant ballroom. So that's how they generate revenue. So everybody's familiar with traditional operable walls? Anybody think that little guy's going to put that wall in place by himself? Not going to happen. They usually, those are usually put in place with 2 teams, because you have to walk the full length of the opening, and the walls are probably, each panel is probably 700 or 800 pounds. So it'll take a couple people to move each one of those panels into place, and then lock down all of the seals properly. All electrically operated walls take 2 people, and so obviously it costs less. If you think about a 60-foot long wall, 20 feet high, it can be in place electrically in a little over 2 minutes. It would take well over the hour that this bar graph shows to actually put the wall in place and lock down all the seals properly. I keep saying that because most of the time when I go see those, I can kind of look down on the floor and say, no seal. Can't complain about the acoustics if the seals aren't in place. How about moving the wall? You don't need any special tools when the wall's electric. We all learned how to push buttons and turn keys when we were about 2. So there's no special training, and we don't have to worry about anybody getting an elbow or fingers caught between panels. And also, there's not fingerprints at the 4-foot mark where somebody's pulling panels out of their storage pocket or pulling the panels away from each other as they're trying to put them away or put them together. The more reliable acoustic performance is as those panels run back and forth across the track, you're going to degrade that top seal. They have a fixed top seal. And as you roll back and forth, you're going to degrade that seal over time, and eventually the acoustics of the wall will change. And also with an electric wall, you can interface with other parts of the operation. So we can say, hey, when the wall's down, I need more light on each side. Or when the wall's up, I don't need so much air. And all of that can be handled through a control panel for an electric wall. So there are 3 types of electrically powered partitions. First one in this presentation calls it horizontal sliding. That's a traditional operable wall, electric. It's wall stacked, just like the manual version. About 7 years ago now, the vertical stacking wall entered the market. It's ceiling stacked. And then the vertical folding wall entered the market in 1993, and it's ceiling stacked. So I'm going to give you a little description of each one of them, try to give you an idea of where we go from here, maybe. So the first thing you're going to see is an electric, traditional operable wall electric. Depending on where you're sealing that wall, In this case, it's sealing to the back of the pocket, so you're going to actually stack the panels in front of the pocket and then shift that whole stack into the pocket. So when they're electric, the way they create their acoustics is to nest the seal from one panel into the panel next to it. They are continuously hinged together. You'll see MDF boards occasionally. Most of the time you're going to see base panel. They use MDF to light the load when the wall gets really big and heavy. So as I say, continuously hinged together. In that track, you still have a sealing track. And in that track is either a chain or a cable that pulls those panels out into place or pulls them back to their storage pocket. They have, most of the time you're going to see a butt hinge, like a door hinge, exposed hinge. Some manufacturers will do a semi-concealed or a soft hinge or a piano hinge if you're asked for it, if you ask for it. All of them have a fixed top seal still, so you're still running back and forth across that track. And then the bottom seals, I'm going to point at this, and I'm sorry that you guys can't see it, but where you see the little seal in the bottom of the panel, all the manufacturers call that something different, whether it's automatic or it's fixed or it's floating. Essentially what happens is when the wall gets to the straight position, the seals either settle out of the bottom of the panel or there's something in the astragal that gets tripped that says drop that seal. Technically, when they're electric, they go up to an FTC of 56. What you need to know as designers is that the higher the FTC, the lower the maximum sealing height. All of that is weight related. So how much can a chain pull in and out of that storage pocket? That's what they're dealing with. So at an FTC of 56, they tell you they weigh 14 pounds per square foot. Going to need heavy structural support. Most of the time you need a structural I-beam of some kind to hold that wall. They max out when they're electric at 28 feet high and 108 feet wide. Know that when they go 108 feet wide electrically, you're going to have to stack on both sides of the opening. Now, I'm going to pull all those panels to one side of the opening or the other. They run in a straight line. They do a 90-degree or a T intersection. The finishes are limited to anything up to 3/8 of an inch thick. So you'll see vinyl and they have standard fabric, and you see they have standard carpet for the wall. You'll see wood veneers, you'll see graphics, you'll see paint. Use your imagination. Just remember 3/8 of an inch. If you have to have egress through the wall, this is the only one that's going to put a pass door or man door through the wall. Nobody else is going to cut a hole through the wall, and the reason is for every pass door or man door you put in a wall, you lose one STC point to get started. Problem is, and I don't know, I can't point to it for you guys in Virginia, but underneath the door, the pass door, if you look at it, there's a gap. James has the best description of that.
The screen door and stuff.
So a screen door recovery. It's a 2-inch hole that will allow sound to go from one side of the wall to the other. It can't put a solid seal there. Wouldn't be able to open and close the door. So they use a 2-inch brush seal under that door. So as I say, that's technology. The manual walls started in the 20s. They've made an electric wall early in the 60s. They haven't done much changing to that technology. I understand there's some changes coming, but we haven't seen that yet. Vertical stacking walls entered the market about 7 years ago, as I say. And this video will show you sort of how they operate. If you think about the horizontal sliding wall, turn it on end. That's really what you're talking about. The stack of panels that you see on the video is actually cantilevered over the opening up top. You're going to drop one panel at a time into a slot or pull one panel at a time out of a slot. So the red box here is to indicate there's a steel, those panels are encased in a steel box that's actually cantilevered over the opening overhead. You're going to drop one panel at a time into the slot, pull one panel out. They still have track. They call it side guides now, and that's on both sides of the opening. So that's what's pulling those panels up. There's chains running in those side guides, and that's what's pulling the panels up into place or pulling them down into their stored or into their extended position. The brush seals are what they use on the sides to cover those chains. The reason for the hand there is that it was actually, for you guys, it probably makes a lot of sense. We were competing for a project, for a K through 12 project. If you know that chain is in there, you can put your hand through the brush seal and put your hand around the chain. Not exactly safe in a elementary school, or even in a high school where they might put gum or something wonderful like that in there. But that's the reason for the hand.
Question.
Okay? Yes.
7 and 8 is just like the
The big part?
Is that your detail?
No, that is their detail. Semi. They can't fully recess it because if you fully recess the side guide, you can't get to the chain to fix it should something happen. So they will semi-recess some of that. The overhead stack you need in the plenum is 44 to 51 inches. So a lot of space in the ceiling. Acoustically, they do an FCC of 51 only. And at 51, they tell you they weigh 11 pounds per square foot. Here's where it gets tricky. They max out at 17 feet high and 40 feet long. That's the biggest wall they can make. You're going to need to support it structurally on both sides of the opening, because you're going to rack on both sides as those panels are moving up and down. Here's one thing they don't tell you any place. Has anybody ever seen a freight elevator that's going to hold a 40-foot long panel? Probably a ground floor application. Or you could leave a window out and slide panels in, but it's pretty late in construction when the panels get there. So that's not, just make a note for yourself. They run in a straight line only, so no intersecting walls. And their finishes are really standard. They're standard vinyl, they're standard fabric, they have standard carpet for the wall. They just introduced marker surface, so that's something they're beginning to use. And then they will do some limited COM, so make sure if you choose something that's not standard that you let them look at it ahead of time. Again, they've been around about 7 years. We probably now know of about 75 or so projects around the world. Vertical folding walls entered the market in 1993. And this will show you, the first thing you're going to see is a conference room type space. The wall will accordion from the ceiling to the floor or accordion back into the ceiling. So little spaces like conference rooms or classrooms, or then big giant spaces. This is a hospitality, we also have gymnasiums, convention centers, a little bit of everything. This is a really big application for us these days, and that's on the stage, in that they can acoustically treat the stage and then use that as band room or someplace else and not interrupt what's going on outside that space. Here's why it's different. It's 2 walls. So you get a steel face, a honeycomb core, a blanket of insulation, then weave an 8-inch dead air space in the middle of the wall and repeat the sandwich on the other side. So in the down position, we're 11 3/4 inches wide. What you see running in that little corner over there on the left-hand corner is actually a different model. It's called a Zenith, but the difference is simply in how it unfolds. It unfolds at the ceiling and comes down flat. So we only need 14 inches clear when it moves down the wall. Because we have 2 walls, you get double seals at the top and you get double seals on the floor. And all of our side seals are actually stored inside the wall. So you'll see the wall come down, and then you'll see the seals cam out of the inside of the wall to fill that space. We run about 1/2 to 3/4 of an inch off of your fixed construction when we're moving up or down. So we don't require any backing in the wall or any kind of jam. And we don't have any tracks. So no tracks on the floor, no track on the wall, no track on the ceiling. what looks like, and it's hard to see now because it went to white, but what looks like track in the ceiling is actually the double bottom seals for the way the wall folds. Technically, we do an FTC of 48, 51, 55, or 60. And even at 60, we only weigh 9.4 pounds per square foot. So we're half the weight of the other options and a dead load on the structure. We max out at 36 feet high, and we'll go as long as you'd like to go. I'll tell you that the longest wall specified today, the contract is on its way in, it's 612 feet long, 28 feet high. It's segmented, and it's filling the second level of the arena at the University of Texas, so that when they have an event where they can't fill all the seats, they can close off some of the space. So we run in a straight line. We do a 90-degree, a T intersection. We also do an L intersection or a fully mitered corner, which you'll see come up last here. In that case, they created us at the University of South Florida. They actually created rooms inside a room. So they had 3 sections. Now we gave them 2 extra rooms by creating the mitered corner. Our finishes are anything up to 1/8 of an inch thick. So you see lots of metals really popular. Marker surface has always been popular. We also see a lot of graphics these days that people are actually branding their walls for their spaces. Obviously, fabrics, marker surface. We also have other options available. So we can accommodate a sloped floor. We can accommodate a stepped floor. How about between columns? Where would you stack the panels? Going up, so we don't require any floor space. And then obviously really large walls. These are the competition volleyball courts for the University of Southern California. So let's talk about acoustics. This is usually, it's a test. It's going to be hard for you guys to answer the test, but which medium best conducts sound? Conducts is the word we're after here. It's a solid. Sound is simply a vibration, so it's going to move along that solid track. I always tell a story on myself. I was doing this presentation for about 30 millennials, and I said, do you remember when the cowboys and Indians used to put their ear on the railroad track, and every face in the room was just blank? Like, what is she talking about? That's simply a vibration. You could hear the train coming by, putting your ear on the railroad track. These walls are all designed to do 3 things. They either keep sound in the space, they keep sound from leaving the space, or they keep sound from bouncing around inside the space. We do that with a couple of tests. The first one is an STC. That's the sound transmission class. Everybody who walks through the door is going to tell you they got the best STC available. Let me simply say STC is a lab test. That's what you need to know. Everything is absolutely perfect when any of us test. The NIC test is the test you want to know. You have an NIC test for that STC. The NIC test is actually in place with all of the ceiling, floor, furniture, so that you get a real life feel for what you're going to get. And then some of the walls actually are like ceiling tile in that they absorb sound. So rarely do we sell a wall full of NRC panels. What we sell is a wall, and they'll say, an acoustician will say, I want these panels to be NRC panels, or I want this row to be NRC panels. And what they're doing is tuning your space, so you aren't getting the reverberation you would get from a lot of hard surfaces. And that obviously is available to you. So the STC and NIC tests are very similar. They blast white noise on one side of the wall, and then they measure it on the other. So very simplified, if you blast 100 dB on one side, and you measure 60 dB on the other, you have an STC of 40, or you would have an NIC of 40. What actually happens is, this is a real test. This is a test done in 2004 achieved an NIC of 46. They actually, for those of you in Virginia, that octave band column all the way to the left, they tested all of those octave bands and then they averaged to give you your NIC. So in this case, we went STC 51, achieved an NIC of 46. That's about as low as we go on a 51. We've gone as high as a 50 on a 51. So you're also dependent on surrounding construction. When the vertical folding wall entered the market, we knew that our acoustics were much better than what you've seen for a long, long time. We knew the 8-inch dead air space in the middle of the wall had something to do with it. There had to be something more to it. Well, we finally got wise and read the acoustic tests for our competition. And what you see is when traditional operable walls test, they don't test with the bottom seals, nor with the expandable or bulk seal that you're going to meet on fixed construction. So what you're really getting is a panel test. So we said, well, maybe that's something to it. Let's go back and see what our panel tests look like. And so that's what you see. On our lowest full system test of 48, STC 48, we have a panel test of 57. That's higher than anything else on the market today. And then obviously to get to 60, which everyone has tried to get to for a very long time, our panel test is a 66. And this is a comparison of all of those other products. So everybody has an STC 51. But what do you get when you get that 51? And you can see sort of where their tests, everybody's tests fall. As I've said before, surrounding construction is a big part of this. So we want to know that the surrounding construction is equal to or greater than the wall in STC. The only thing I point out here is that one that says double 5/8 drywall and steel studs, because every time I walk into an architect's office just to talk about a project and they want to talk about, I want 60, I want the 60, I want the best thing you got. Do you really? 25% more in price. Is it really worth that much? And what I tell you is that in some places it makes sense. Performing art, some place where you're going to have amplified sound, 60 makes sense. But go look at a 51, vertical folding 51 first, because you can't hear from one side to the other. That's something that is new. And then you aren't going to have to pay that 25. But 25% increase. But what I do point out is if you're going to really need the 60, you're going to increase the cost of construction in that space. So where the wall is located. Where does sound come from? Every place you can imagine, every crack, every crevice. They tested a project in D.C. some years ago that actually lost 3 points through the knack of the carpet. So no fluffy shag carpet underneath the operable walls, whatever kind they are. Sound control is also a function of the mass of the wall. So the thicker the wall gets, the more material used in the wall, the better you're going to be at stopping sound. And as I said, the vertical folding wall is 11 3/4 inches wide. The 4-inch walls are STC 52 and above. When you go down to 50, you're at a 3-inch wall. So which wall's acoustically better, right or left? Anybody got a guess? Are you sure? The dead air space in the middle of the wall allows the sound to bounce around and not pass through to the other side of the wall. So acousticians tell us that we actually would have, if we took the right side and we staggered where the stud placement was, we could also have gotten higher than the 63. So I know you all lay in bed at night and think about operable walls like I do. So what else do you think about? How about wall size comparison? As I said before, the vertical stacking wall goes 40 wide, 17 high. Traditional operable walls, electric, go 28 high, 108 wide. And we will go 36 feet high and as long as you'd like to go. And James would love a 613-foot wall, please. So let's talk about structural support. This was a big one for those of us who work for the company. We had an owner who always told us we save 40% in structural support. And we'd say, well, that's really good. How? And he'd say, I don't know, I've been doing this a long time. That's just what we say. We finally convinced him to let a structural engineer design more sides of walls for us so we would understand where we fell in that market. And the first thing he said was, I don't even know why you ask. You're a dead load on the structure. So once we take the weight and we spread it across the opening, we lift and lower the same amount of weight, the same place every time that wall moves. So if you're used to traditional operable walls, they're a live load on the structure. So the stack of panels, wherever it is, determines the size of your structure overhead. So usually it's in the pocket, but you also don't want, in a former life I sold those kinds of walls, and I got the Saturday afternoon call that the janitorial crew came in and they wanted to vacuum in the closet, so they moved all the panels out in the middle of the room, and now we can't get them back out of the middle of the room. So that stack of panels, that stack of weight will always decide what your overhead structure is. So what it meant for us, we used a 24 by 9, which is a fairly standard size wall. 24 by 9 traditional operable wall electric weight needed 1,100 pounds of steel. The vertical stacking wall, you're going to have to prepare for it to move on both ends of that opening. It used 1,500 pounds of steel. The vertical folding wall used 216 pounds of steel. And for this exercise, we forced the structural engineer to use I-beams. For us, most of the time in the vertical folding wall, if you're at a 24 by 9, you're going to hang from C8 steel channel. We don't use I-beams. So there's a huge savings there for designers, but you need to know that before it goes in. I have yet to see a general contractor say, I didn't use all that money I had planned for the steel, so I got some design dollars to give you back. Doesn't seem to happen, so we want you to be aware. This is the same thing, just showing you that the vertical folding wall is a static load, while the horizontal wall is a dynamic load. How about safety? It's become a bigger issue as probably most of you in this area know. Traditional operable walls only had, when they started out, they only used one key. Now, all of these walls use 2 keys. And the 2 that come out of the ceiling are standard with auto reverse or leading edge protection, so it'll come down if it hits something, it stops, and it reverses, and it sits there until you remove the obstruction and try again. I think probably that's more than an option these days on traditional operable walls. It's coming if it isn't. Yes. It's not mandatory today. July 1st it is, I know. The other safety features, traditional operable walls offer you pressure pads for the pocket. They're there to detect weight. But when they originally brought these walls out, they thought when the wall's fully extended, it's an empty closet. Kid could hide in it. Nobody looked. You could seriously hurt someone. The pressure pads detect weight. So if you set it at 50 pounds and there's 50 pounds in that closet, the wall won't move. Last time we heard somebody stored chairs in one of those closets and it blew them through the fixed construction at the back of the pocket. So something you might want to consider. And then the infrared path is like your garage door. It's probably the best offering, but the problem is that between the red lines or the lasers, your owner has to agree to take everything out of that space or the wall won't move. That sometimes works, sometimes it doesn't. So, how about storage? How about floor space? That has value. Traditional operable walls or horizontal sliding walls are going to always have a pocket that's about 5 feet wide, and the depth depends on how many panels you're going to put in that pocket. Vertical stacking wall, no floor space. They're going to use that 44 to 51 inches of plenum space to stack that in the ceiling. And I want to be really careful here. This is really specific to this market, to the DC market. We have a motor that will take us up to 9 feet high that we can store in 23 and a half. 23.5 inches for the whole wall. Once you get over that, so you go to a 10 foot, you're going to be at 2'8", 2'7", 2'8", 7. So no, still, again, no floor space. And that's what this is just reiterating. So way cool, right? Hmm? Sure.
How about red?
There will be none, the only one, the horizontal sliding wall, the only one that's going to cut a hole through your wall.
Well, in the horizontal one, push the pad and it comes back. So in the vertical one, there's no way to get through it.
No, not through the wall itself. We have other ways to design around it, but yes. So if we look at just the price of the wall, this is sort of what it looks like. So when horizontal sliding walls are probably 3 times less in price than a vertical folding, just product only. Vertical stacking walls entered the market at about 15% less. But when you add that steel back I told you about, the vertical stacking wall becomes the most expensive, and the walls get closer together. And if floor space has value and plenum space has value, the numbers do get a little bit closer together. It's the next step that we're finding day by day really makes a difference. The vertical folding wall gives your owner a 10-year warranty on the acoustics of the wall and a 10-year warranty on all the parts of the wall as long as they service the wall. So we know that we're not running into it.
Sure, one of these things are based.
They do. They play basketball, volleyball. The only thing I've really ever seen damage a panel is somebody ran a forklift into one. And then I watched it and saw it take the panel off, it only takes 2 screws to take the panel off, and hammer out the dent, pull the fabric tight, and put it back on, and you wouldn't have known it got hit. So
It's a pretty rigid system.
it is.
Is it identical about what it is?
Not stupidity, right?
Where's her?
We can see a lot of that right on the school spec, like conditional damage warranties.
So, in summary, obviously, this is the AIA presentation. Well, in summary, report. You got it, right? I'm going to show you the latest and greatest in operable walls.
Any other questions?
So this is Skyfold. This is not the AIA presentation. Obviously, Skyfold is who I work for. A lot of the new products, the new stuff we come out with comes from you guys. We're listening. My engineers kind of enjoy a challenge. So keep that in mind. If there's something you want and you don't see it, ask Jay, ask me, and we'll send it to Canada and see what they'll come up with. But we did come up with something new, all driven by an architect. This will give you a little history of Skyfold. So we, as I say, entered the market in 1993, and the only product we had was a classic 51. Since then, we have the 51, 55, 60. The NRC, anytime you see that, that's the wall that absorbs sound. And the classic is a model that will go unlimited in length and 36 feet high. Well, we introduced this, and the first thing that happened is architect said, that's really cool, but can you do that in glass? I said, well, sure we can. So in 2007, we introduced Mirage. Think of Mirage as a frame system, call it a glass wall, but many times we put glass in one row and some sort of lumicore form in the other part. So it is a frame system that you can use for glass or for whatever. Again, 24 feet high, and as long as you'd like to go. That wasn't enough. So some of the school architects said, hey, we need something that doesn't unfold all the way to the floor because we had pinch points, places that little fingers and arms and so forth could get into the wall. And so in 2013, we introduced Seat. See it unfolds as soon as it comes out of the pocket, so it's always flat when it comes down in reach of anybody. We also, at the same time, you'll look and see that we do 51, 55, 60 NRC, and all of a sudden we went the other direction and said, we're going to do a 48. Again, K through 12 was a reason for 48. We as regional managers were all sitting in a room like this, and we said, how do we get off the BE list? What can we do to get off the BE list? 48 is that product. Zenith 48 is about 20% less in price than our Classic 51 or Zenith 51. The only thing it does is take away some of your design capabilities. So it's standard fabric, standard vinyl, or full marker surface. Those are the only three finish options on that wall. But I will tell you that we are spending an awful lot of time in the supermarket these days because of that. So we did get off the BE list, so to speak. This shows you that it maxes out. It maxes out at 12 feet high, but it'll go as long as you'd like to go down. But that still wasn't enough. Architects said there's still a couple of things we don't want. So this will go through hopefully the sound is not on. Canadian companies, when they market with Canadian companies, they like to give us a kickback. So all of our videos have Star Wars music that's on. We try not to play it. Very dramatic, yes. But after we get through this little video, you'll see the latest and greatest is a product called Zenith Premium. The first thing you're going to see is we don't have a key and two push buttons anymore. We now operate from a touchpad. So a passcode is all you need to operate the wall. That's available added to any of the products. So that doesn't necessarily, it comes with this one. But here's the big deal for Zenith Premium, and you'll see the wall come down. And if you know our product, we leave a cavity when the wall is open. We're now going to close off our own cavity. That's your acoustic barrier over the top of the wall. So we know it equals the wall in acoustic. It can have lights. So you can have lights in the closer panel and lights in the bottom panel and never mess up your lighting pattern in the space. You should always get complaints about dark places because we're about 5 feet wide at the ceiling. So this one will go up to 14 feet high as long as you'd like to go. Obviously, we sell all over the world, so it comes in lots of languages as well. So again, it's available not in the 48, it's available in the 51, 55, 60, and NRC. Again, unlimited in width, goes 14 feet high. Comes standard with the 2 touchpads on either end. We're always opposite ends, opposite sides for whatever's operating the wall, and that's the big picture. Standard with the pocket closer. Faster deployment time, I'm not sure that's a point to talk about. But and you can have lights, as I say, in the closer panel and in the bottom panels of the wall. The other thing I'd show you here is that if you're not familiar with Skyfold, if you can see the gray Ys at the top of this isometric, those are the only places we attach overhead. So we attach at about 2'8" off of each end, and anytime 2 panels come together. What that means for you as designers, you can run conduit, water pipes, even HVAC over the top of the wall. Not the best place for air, but if you need it, many times in a renovation, it needs space. So that is available to you. And then with the new, and we'd always ask you to have 2-foot drywall up the sides of the wall, over the top to create your acoustic barrier, and then 2 layers all the way up to the deck for acoustic separation. With the Zenith Premium, now that changes. You're only going to go 2 layers of drywall up the sides of the wall all the way to the deck. Because the closer panel will be your acoustic barrier over the top of the wall. Sound from transversing. The other thing that's happening is with the Premium, we can get in some tighter spaces than we could before. So here, the white ones are the same. The green are less space than the Zenith prior, And then the pinks are the only two that are 2 inches or that ceiling would take over the head. For a little bit wider, we have to have an angle that holds that acoustic panel when it falls down, so that increases the width of the wall just a little bit. That is the premium and the latest and greatest Optical walls. That's all I have to talk about today. Any questions? Anything I can help?
An example of cost for the 9 by
24 by 9?
Yeah.
Okay, your territory.
You're probably, depending on that, minutes, you could range, quite honestly, I know between like 65 to 85,000 installed. Finish goes a long way, and there's certain, so for Skyfold, you understand we're the most expensive option for Optical walls. We don't shy away from it. We're a pretty good product for reason, way before. But there are certain things that we will try to direct you guys to do as far as Partitions size. So Skyfold's maximum panel length is 12 feet. So if you have an opening that's 25 feet, for a custom wall, we'll build you anything. But I'll then also give you an option for 24 feet in the That also works in the vertical and the number of panels in the ceiling as well. So we are mindful that we're in that process. We don't want to artificially inflate it. And with that, some of that range I gave you, panel size can sometimes be double a fabric allowance because the panel is wide for a whole fabric. So there's certain kind of no hard and fast rule to say 24 by 9 will always be good. You're in that range. Probably I would tell you probably about 70,000 installed. That ballpark with an additional wall somewhere around 20,000. So that's almost 3 times the question. And also the smaller walls also cost more per square foot because our motor commonly costs the same, our head seal is the same, but less square foot there's damage drive that cost over. So they're very large partitions, so the square foot cost is massive.
I would tell you the best way to sell a wall is to call James. He's local and say, hey, I need to have a wall party. We need to take these guys and kick the tires and see a wall. That usually turns the tide for us. Once they understand how it works and why it works and the fact that it does stop sound, then it's a lot easier to.
It made a huge dividend. So
Yeah.
At Georgetown University, they consider themselves relatively intelligent. Their first option, they were looking at Skyfold for this teaching amplitude. And GC, we provided everything to the architect. They called us and said, hey, we're smart here. Why did this one cost more? So we took them to a like-size partition. The wall was in the upper position, 8-foot-tall walls, halfway down. Decision makers, if they hand up, he's already got it. He understood the difference as opposed to a manual wall that each and every time they'll be moving across the stage versus something that came down. We asked them to make the noise. They had to call their counterparts on the cell phones. They can't hear them. He's like, this makes all the sense. No why it costs. Still their choice to spend the money to purchase it. That was wall 1. They're on their second wall. Just getting in front of the system so they can understand the differences. A GC with a spreadsheet, your numbers is not going to play. And with
I would encourage you to let us help.
The N48 is helping us in terms of having a backup, and providing tiered pricing. But again, the GC tends to look at that as an equipment option. And again, I would tell you in this market, we haven't had the penetration of K-12 as much as like. I know that Grim as a company has. We're in Tennessee, Health Center, some other areas, Montgomery County, Kensington Parkwood, probably like 10, 15 years ago. But just getting people to see them and understand the differences goes a long way. And now we have one in G County, School Grove Elementary School, to be able to take them to some of the market. Doesn't help me taking someone from a K-12 to a higher ed or to something installation. Having them go to somewhere where they see the same language, how to use the wall, goes a long way.
James loves quote practice. So by all means, run him by him. He can let you know sort of what a particular application will cost. He'll help you lay it out, whatever, help you kind of find the best.
We're not naive. We know we're expensive, and some of these wall tools and they're simpler design where there's 10 to 15 plastic partitions. That may not be the best application for Skyfold in terms of the dollars and cents situation, but we do feel like the stage situation, those applications where getting the partition into the school to start, we'll start to build an understanding of how it one day and called it politically collectible. But why would you say that? It doesn't discriminate for operators. Somebody in a wheelchair can operate time. You know, we don't have that special skill set or usually trained. But we could all set up a manual wall and get different sound results based on our comfort level. We're good at the product and we got it. Go to that side of the give out that office. There, I mean, this is that.
You need, access standalone for containers.
Only
do.
using drywall. As far as
If you have a hard list, we have to have it. Otherwise, we put,
your ACT meeting to a drywall, it would give us the access with ACT at the top of the pocket. In this drywall, just an active panel.
anybody else? Thanks so much for your time. Make him give you a quote.
And that's another thing, we are, even if it's early in your design, we're quick to turn around, you know, a relatively accurate budget from the start, within probably 48 hours, just if you want to see if it's viable based on the dimensional requirements for your project. So.
How much was that last one cost?
It's about
$6,000 and
it can be depending on what kind of glass.